Hello students, welcome to Narayan PU College online classes. So in the last video we have discussed up to the preparation methods. Now preparation methods, and also we have completed physical properties of the alcohols and phenols. And the next one is chemical reactions of alcohols. Yeah. So now alcohols act as both the nucleophiles and electrophiles. Clear? Alcohols can act as both nucleophiles and electrophiles. Yeah. As you already know what is the meaning of nucleophiles and electrophiles. Nucleophiles means electron rich species. Electrophiles are electron deficient species. Clear? So nucleophiles, they have either the negative charge, they possess either the negative charge or lone pair of electrons. And here electrophiles have, means they possess positive charge or empty orbitals. Clear? And first just assume whenever alcohol acts as a nucleophile, when it acts as a nucleophile, and here OH bond breaks. OH bond breaks. See, whenever alcohol acts as a nucleophile, which bond will break here? OH bond will break. Clear? See, simple example. I will consider one example here. And alcohol, the general formula for alcohol is ROH. Clear? And plus, I will take here, when it is act as electrophile, means there should be one nucleophile to react. So take the one electrophile here. So I will take this is the electrophile. It is act as a nucleophile. And now nucleophile will donate the electrons to electrophile. So I have written here electrophile. Clear? Now you know that alcohol here act as a nucleophile. Nucleophile means what it is? It donates the pair of electrons to the carbon and make a bond. Then what happens, you see? And you will get the compound is R, O, and here C double bond C and H, and oxygen is losing electron, it is donating electron, so it acquires the positive charge. Clear? Now, during this process, you already know whenever the positive charge is present on the oxygen atom, it is unstable. It tries to neutralize by gaining the electron from hydrogen, that's electronegative element. So then what happens, you see, you will get the compound is R, O, and here the bond plus H plus. So which bond breaks here? You see, OH bond is breaking here in this one. When the alcohol is act as a nucleophile, that one I have written here. Yeah? Second one, when the alcohol act as a electrophile, when alcohol act as electrophile, when act as a electrophile. Clear? So actually protonated alcohols, you know, protonated alcohols act in this manner. Yeah? Now you see what it is. It acts as a electrophile. Means which one acts as electrophile? Commonly protonated alcohol acts as a electrophile. Protonated means you already know OH actually. Protonated means it takes the proton and it acquires the positive charge. This is protonated alcohol. Which proton is added to the alcohol? Clear? Now it is treated with, it acts as a which one? Electrophile, because it is acquires with charge. Positive charge species will be considered as a electrophiles. Clear? So that's why it is electrophile. So there will be a nucleophile. I will take nucleophile. react with electrophile. Then what happens you see? Then this make a bond here with the alkyl group. When it is making a bond, this bond should break and it will move towards the oxygen, and then the positive charge on the oxygen will be neutralized. Then what you will get, you see, you will get the RBr plus H2. This is the reaction. Yeah. Now you see, in this case, alcohol, which bond breaks here? CO bond breaks. When it is act as a electrophile, which bond breaks here? CO bond breaks. CO bond breaks. This is important. Yeah. So see here in this one, this is alkyl group. Alkyl group means which one? Carbon. So when it acts as a electrophile, this bond is breaking. This is which bond? Carbon and oxygen bond. So that's why mainly alcohols, when they involved in the reactions, mainly two bonds will break. One is the OH bond of the alcohol, another one is CO bond. Based on this concept, the reactions of alcohols are divided into two types. One is reactions involving cleavage of OH bond. Cleavage of which one here? OH bond. And the second one is here, same, reactions involving cleavage of CO bond. Which bond here? CO bond. So these are chemical reactions. Means now we have to discuss about the reactions involving the cleavage of OH bond, and second one, reactions involving the cleavage of CO bond. And the next one, reaction means alcohol as a whole, they involved in the reaction. That is periodic category. So we will discuss that one later. So that's why first we will discuss about reactions involving cleavage of OH bond. After finishing this, and we will go for the second type of the reactions, that is reactions involving the cleavage of CO. And now we have already discussed, and the reactions of alcohols are divided into two types. One is reactions involving the cleavage of OH bond, and another one is reactions involving cleavage of CO bond. First we are going through reactions involving cleavage of OH bond. So in that one, first heading is acidity of alcohols and phenols. Yeah? And what it is, whenever alcohols, you know, the formula of alcohol is general formula, that is ROH. Whenever ROH is reacted with the metals like, you know, sodium, yeah, then, and it will convert it into metal oxides. Yeah, means, you know, and H will be replaced, and take the 2 moles here and take the 2 moles, then you will get the 2 moles of RONA plus what you will get here? Hydrogen gas will be released. Sodium alkoxide. This we will call as a sodium alkoxide. Clear? This is sodium alkoxide. In the same way, suppose I will write here example C2H5OH. C2H5OH plus. If I take here magnesium, take the magnesium. Magnesium means take here 2 moles. Then what the compound you will get? C2H5O and twice Mg plus what it is you will get? H2. This is H2. Yeah, because hydrogen gas is released. In the same way, I will take here tertiary alcohol, tertiary butyl alcohol, CH3, and OH. When it is reacted with the aluminum, you know valence of aluminum is 3. So that's what you will get here, and you will get CH3, and here CH3, and you know O, and 3 times here aluminum. Aluminum tertiary butoxide. What is the name here? Aluminum tertiary butoxide. Tertiary butoxide. Now balance here. You have to take how many moles here? 3 moles. If I take the 3 moles, hydrogen gas should release. Then what will get? 3 by 2 hydrogen you will get. So that's why fraction is there. Multiply over the equation with the 2. Then what you will get here? You will get the 3 moles here. And if it is 6 moles, 3 moles I have taken by 2, means you take here 6 moles and here 2 moles, and you will get the compound is here 2 moles, and you will get and 3 hydrogen gases. Clear? And in the same way, phenol, when phenol is reacted with the sodium metal, then you will get the compound is sodium phenoxide. What it is here? Sodium phenoxide. Sodium phenoxide. Take the 2 moles here because hydrogen gas should release. So take the 2 moles. Means then you will get the hydrogen. See, it means what is the relation between acidity of alcohol phenols to these equations? Clear? You already know that whenever metals reacted with the acids, they produce as hydrogen gas. Clear? Metals reacted with the acids produces which gas here? Hydrogen gases. Now you see, now metals reacting with the alcohols and phenols and produces which gas here? Hydrogen gas. Means what does it mean? And these alcohols and phenols are acidic in nature, then only it will react with the metals and produce the hydrogen gas. Means by these reactions we can say alcohols and phenols are acidic in nature. That is the concept. And next one is we have to take the second one, acidity of alcohols. Acidity of alcohols. Acidity of alcohol. This is very important concept for the PU as well as competitive examination. Clear? So many questions may come from this concept. Which different types of questions. So many, not 1 or 2 questions, but different types of questions may come. So how to solve, we will discuss here. Now, acidity of alcohol, I will take first of all primary, secondary and tertiary alcohols. Clear? Just I will write here primary alcohol CH3CH2OH. This is the primary alcohol. And secondary alcohol, you know, CH3 and CH3OH. Yeah. And last one is take the tertiary alcohol CH3 and CH3OH. This is first one is a primary alcohol and the second one is a, if you know OH is attached to CH2 group, it is a primary. OH is attached to CH group, it is a secondary. OH is attached to the carbon not having any hydrogen, so it is a tertiary. Okay? Now, in this case, which alcohol is more acidic, you have to identify. Clear? So, very important, I am saying, to know the acidic character of different alcohols, you must remember here 2 concepts. And 2 ways, by 2 ways we can explain the acidity of alcohols. One is, first one here, you know acidic means, and the molecule should release the H plus ions. And here H is attached to highly alkyl atom, and here also H is attached to highly alkyl atom, H is attached to highly alkyl atom. All can produce the H plus ions, but you have to identify which one is the more acidic. You know which compound and gives H plus ions very fast, that is the more acidic. Okay? Now how to do this one is, first of all, whenever they give the alcohol, clear? First you have to see, you have to write, you know, RO minus and H plus, because it gives the, because H is attached to highly alkyl atom. You know, oxygen is more alkyl atom, the bond electrons towards the oxygen is gaining electrons, hydrogen is losing electrons. So that's why oxygen negative charge, hydrogen positive charge. And here the acidity of alcohols depends upon stability of the ion left after the releasing of H plus. Clear? Again, the acidity of the alcohol, it depends upon the stability of the ion left after the releasing of H plus. If this ion is more stable, if the ion is more stable, this alcohol is more acidic. That is the first one. Mostly remember this one. Clear? And second one is here ROH. Clear? And you know, and here the bond breaks and it gives the H plus ion. Now, if electron density is more in this alcohol, suppose it is electron donating group, it donates electrons to OH, then and here on the OH electron density will be high. So means the electron density between the OH bond will be more. More means what it is? It make like a double or triple bonds. So that's why this bond will not break easily. So it is a less acidic. If electron density is less on the OH bond, then it releases the H plus ions very fast. Clear? So these are the two concepts you have to remember. First one, see the ion. And if ion is more stable anion, then the acid is more stable. If electron density on the OH bond is high, electron density on OH bond high, then less acidic. Because more electrons means it will form some other bonds here, so its bond breaking is different. If electron density on OH is less, then it is a more acidic. This is the concept. Yeah. So then we will explain among the primary, secondary, and tertiary which one is more acidic. I will explain. Now see here, primary alcohol, secondary alcohol, and tertiary alcohol. So you have to identify. All are acidic only because all can give the H plus ions. So that's why all are acids, but you have to identify which one is more acidic. And I already said in two ways we can identify the acidity of the alcohol. The first write the anion of this alcohol, RCH2O minus and H plus, and here also I have written. Clear? Now you know that here alkyl groups are electron donating groups. Alkyl groups are electron donating groups. They donate the electrons to CH2 and CH2 donate the electrons to O minus. Means on the oxygen electron density increases because already minus charge is there and these are giving electrons to oxygen. Electrons means negative charge, so that's why on the oxygen negative charge increases. Clear? And here, how many groups are giving electrons here? Two groups are donating electrons to the oxygen. And here, three groups are donating electrons to oxygen. Clear? You know that in this case, electron density on the oxygen will be very, very high. And in this case, electron density will be less compared to the third one. Clear? Now, you know that one important concept in the first year, so many times we have discussed. You know, charge is inversely proportional to stability. Charge is inversely proportional to what it is? Stability. Greater the charge and lower will be the stability. Clear? So that's why in three cases, which alcohol anion is having high charge here because three groups are donating electrons. So that's why on the oxygen electron density will be very, very, very high. So that's why it is having high charge. If it is having high charge, stability will be less, least stability. It will have least stability, and it will have least stability. Clear? But come to the first one. First one, charge is less on the oxygen, negative charge is less, charge is less, stability will be more. So it is more stable. It is more stable. And it is least stable, and it is the most stable, and it is more stable. Means intermediate between these two, and stability will be there. You know that, and stability of the anion is high, and the acidity will be very, very, very high. So that's why. And which alcohol is having more acidic, and primary alcohols are more acidic than the secondary alcohol, than the tertiary alcohol. This is the concept. Clear? And in the same way, second concept I have discussed here. Second concept means what you have to see. You have to see the electron density on the OH bond. One group is giving electrons here, and here two groups are giving electrons here, and here on the OH, this OH having the this OH bond is having the more electron density. More electron density means this bond will be strong. It won't give the H plus ions very easy. And it is less electron density is there between the OH, and it can easily gives the H plus ion. In that way also you can. But this is the preferred method always. See the anion stability. Which anion is more stable, and that alcohol is the more acidic. Yeah. So this is about the acidity of the alcohols. Yeah. Next one. If you compare the acidity of alcohols and water, so this is also comparison of acidity of alcohols and water. So which one is more acidic? Because alcohol means ROH, water means HOH. Yeah. So this is also H is attached to highly electronegative atom. Here also H is attached to the highly electronegative atom. They can give the H plus ions, and here also H plus ions. Both are acids only. But which one is more acidic? That we have to identify. Simple method. First write the anion of that acid. It gives the H plus ion, and here electrons will shift towards A. And right here, if I take this is, and here H, O minus and plus, H plus. See the which anion is more stable? This is alkyl group. Alkyl groups are electron donating groups. So that's why it donates the electrons. On the oxygen atom, electron density increases. If electron density increases, charge increases means automatically stability will be less. So this anion is less stable. This is less stable. But here hydrogen is not electron donating group. So that's why it cannot donate the electrons to O minus compared to here oxygen. Here oxygen is having the less charge. So that's why charge is less. So stability will be more. So this is having anion is more stable. If it is more stable, that molecule is more acidic. So that's why, and here alcohols are less acidic than the water. But in the PU examination sometimes they will ask why alcohols are less acidic than the water. Simple answer you have to write because of plus I effect of the alkyl groups. Because here which effect we will say? It is donating electrons to oxygen. Which effect here? Plus I effect we will say. This effect we will call as which one? In the first year we have studied plus I effect. Donating electron means plus I effect. Withdrawing electron means minus I effect. It is donating electrons to oxygen. So that's why which effect here? Plus I effect. That you have to write. What is the reason means here? In the sometimes PU examination they are asking why alcohols are less acidic than the water means because of plus I group or plus I effect you can simply write plus I effect of alkyl group in alkyl group in alcohol. That you have to write. Yeah. So this is about the acidity of alcohols. We have discussed acidity of alcohol, and also we have compared acidity of alcohols with the water. And what is the reason here why alcohols are less acidic? Because of the plus I effect of the alkyl group in alcohol. Yeah. So next we will discuss about the acidity of phenol. Next one is acidity of phenols. We have discussed acidity of the alcohols. Now next topic is acidity of phenols. After completion of acidity of phenol, we have to compare the acidity of phenols and alcohols. That we will do later. And first of all, acidity of phenol. Yeah, you know what is the phenol formula? In structure of phenol is on the benzene ring, and there will be a OH group. There will be a OH group. This will be called as a phenol. And as you know, the OH is attached here is sp2 carbon. It is attached to which carbon? sp2 carbon. So that's why you know electronegativity order. sp hybridized is more electronegative than the sp2 and sp3. So that's why it is a sp2 hybridized. So that's why and due to this sp2 hybridized carbon atoms are present on the benzene ring, they act as electron withdrawing group. They act as a which one? Electron withdrawing group. When it acts as electron withdrawing group, and we withdraw the electron from which one? Oxygen. And whenever and the oxygen, it is withdrawing the electrons from the oxygen, means the on the between the OH bond electron density decreases, so that's why it can give the H plus ions very easily. That is one concept. And another one, you know that in this one, you know oxygen is having lone pair of electrons, and benzene ring here act as a electron withdrawing group. It withdraws the electron from the benzene and it involved in the resonance, and it gives the different resonance structures. Clear? You see now. And in this case, first what happened? Lone pair and double bond is separated by single bond, so it is a conjugation. When it is a conjugation, there is a chance of resonance. So these lone pair of electrons are converted into bond pair electrons, and these bond pair electrons will shift towards this carbon. So this carbon is gaining electrons, so that's why it will acquire the negative charge. Oxygen is losing electrons, so it acquires the positive charge. This is structure. So how it will be made? This will be the structure. So here oxygen plus and H, and there will be negative charge, and here double bond. Yeah, and this bond will become a which bond here? Double bond. Because lone pairs are coming here, single bond is converted to double bond. Again, you know it is again involved in the resonance because negative charge double bond is separated by single bond conjugation. So again, these pair of electrons comes here, converted into bond pair, and these bond pair electrons will go towards the carbon. Yeah. Then what the compound you will get? You will get the compound is, yeah, and here double bond O plus and H plus. Then there will be negative charge, double bond and double bond. And the next resonating structure says this double bond electrons. Pair of electrons comes here, single bond is converted into double bond, and this double bond electrons will shift towards this carbon, and that carbon gets the negative charge. So you will get the compound is, and here negative charge and double bond, and on the oxygen positive charge, and there will be a. And finally, and this negative charge, double bond and negative charge separated by single bond, again conjugation, and these bond electrons will move towards the oxygen. Now oxygen is gaining electrons, so that's why oxygen acquires the negative charge. Already oxygen is having big charge, positive charge, so that's why its charge will be neutralized on the this one here. Yeah? And you see these are resonant structures. So in this one you see, if you observe these structures, oxygen is losing electron. On the oxygen the charge is acquires a positive charge, and on the oxygen positive charge acquires. Oxygen is become very electron deficient, unstable. It will take the electrons from the hydrogen and it leaves the H plus ions very easily. So that's why and phenols are acidic in nature. Clear? And also second one, we can say the stability of and the acidity of alcohols by taking our concept we have already mentioned, and first write the phenol, and after then write it ion, phenoxide ion, and plus H plus. If it is more stable, then the alcohol is more acidic, and you have to check whether it is a more stable or not, and check it here, and you know negative charge will be present on the oxygen atom. Clear? You know negative charge and double bond is separated by single bond conjugation, so involved as a involved in the resonance, and those pair electrons convert into bond pair, and it convert into double bond, and bond pair electrons are converted into lone pair on the carbon. So what you will get here? You will get the compound is, you know, here oxygen double bond on the carbon negative charge, same resonance structures you have there, and this bond will come here, and this I have already explained there in the same way, and here double bond will come, and here double negative charge, and negative charge double bond is separated by single bond, again conjugation, and comes here, and double bond will be there. And now this last structure we have right here is negative charge double bond, and here there will be double bond here. Last one. Again, double bond and negative charge is separated by single bond. Again, conjugation. There is a resonance. Finally, you will get the compound is, and here O minus. Okay. So these are resonating stages. Yeah. You know, whenever oxygen is having the negative charge, it is involved in the resonance stages. You know, whenever the molecule is involved in the resonance, then it will get the more stability. So that's why the phenoxide ion is a very stable because of resonance. It is very stable means this alcohol is a more acidic. Yeah. And now compare here OH and phenoxide ion. If you compare here phenol and phenoxide ion, phenol means, you know, this is phenol, and phenol means when it gives the electrons to this, so otherwise you can see this, and here there is a phenoxide ion. Which one is more stable between these two? One is phenol and another one is phenoxide. Which one is more stable? Because this is also involved in the resonance and giving the three structures, and phenoxide also involved in the resonance and giving the three structures. If structures, resonance structures are same, stability should be the same. But here, if you compare the stability here, phenoxide ion is more stable than the phenol. Why? Because means in the phenoxide ion, when it involved in the resonance, and you see there is no charge separation. Only on the oxygen negative charge. Here on the carbon negative charge. There is no charge separation here. But compare here in the phenol, and on the oxygen is positive charge, on the carbon is the charge, negative charge. There is a charge separation. When they involved in the, it is involved in the charge separation, there is a charge separation. There will be attraction between the positive and negative. Positive and negative means, and negative charge should be involved in the resonance. Due to this attraction, it will involve in the resonance very slow, so that's why it is a less stable compared to the phenoxide. Next one is, just now we have discussed about the acidity of phenols. Phenols are more acidic due to the stability of the phenoxide ion. Yeah, because phenoxide ion involves in the resonance, so that's why whenever it involves in the resonance, so it will get the more stability. So that's why phenoxide ion is more stable. So that's why phenol is a more acidic. Now next concept is comparison of acidity of phenols and alcohols. Suppose phenols means you already know. This is phenols OH. Alcohols means I simply write ROH. Okay. And our concept is there. First of all, write the and ion by removing the H plus ion. So this is the phenoxide ion. Clear? And same here also. And write the oxide and here H plus. Clear? Both are giving H plus only. So both are acids only. Both are acids only. But you have to say which one is the more acidic. More acidic means which ion is more stable, that one will be the more acidic. Clear? Now you see. And in this case, phenoxide ion, just now I mentioned, phenoxide ion involved in the resonance. When it involved in the resonance, it gets the more stability. Clear? So that's why it is more stable, and because the phenoxide ion is involved in the resonance, it will get the more stable. Clear? But now you see, it is an alkyl group. Alkyl group means, you know, electron donating group. It donates electrons to oxygen. Already on the oxygen electrons are there, so electron density increases, charge increases. So when charge increases, stability decreases. Stability decreases means it is a less stable. It is a less stable. So that's why it is more stable. So that's why phenol are more acidic than the alcohol. Okay? In the PU examination, simple question they will ask. Here the question they will ask: why phenols are more acidic than the alcohols? Clear? Because in the phenol, the phenoxide ion is involved in the resonance. Due to the resonance, simply one sentence you have to write. Why phenols are more acidic than the alcohols means due to resonance in phenol. Due to resonance in resonance is involved, OH is in phenol is involved in the resonance, so that's why it is more acidic than the alcohol. So this is the comparison of which one here, acidity of phenols and alcohols. Now next one is comparison of acidic strength in phenols. Yeah, means you know that just now we have discussed acidic strength of the phenols, and phenols are more acidic than the alcohols. Yeah. Now, if any substituents are present in the benzene ring, then how they affect the acidity of the phenols? That we have to discuss. Suppose first I will write here electron donating group, and here benzene and OH. This is phenol. Yeah. Now just assume one group is present here. The group is a electron donating group. This G is a which one here? Electron donating group. Whenever electron donating groups are present on the benzene ring, then what will be the acidic nature of the phenols? Clear? And you know, first of all, whenever acidic nature we are studying, just you have to write the anion of this compound. Write the anion of this compound, ion you write. And this is O minus, and there will be an electron donating group, electron donating group plus what is H plus. Then what you have to see? See the stability of this. If it is more stable, this is more acidic. If it is less stable, it is less acidic. Alcohol is less acidic. Now this is electron donating group. Electron donating groups, what they will do? They donate the electrons. They donate the electrons to benzene. Benzene, what it will do? It donates the electrons to oxygen. So on the oxygen, electron density increases, charge increases. When charge increases, stability decreases. So that's why it is less stable. It is less stable. So that's why after donating H plus ion and OH, this phenol is becoming unstable. Then why phenol gives the H plus ions? It won't give easily. So that's why it is a less acidic. Means whenever electron donating groups are present on the benzene ring, present on benzene ring, it decreases the acidic strength of the phenol. It decreases the which one? Acidic strength of the phenol. Acidity decreases. Clear? And now, if you take here electron withdrawing groups, and here same OH, this is the first concept, and this is the second one. Now electron donating groups we added. Now electron withdrawing groups. The G is here electron withdrawing group. Yeah, same. What about the acidity? When electron donating groups are present on the benzene ring, what happens to the acidity of the phenols? Clear? So here G and here electron. G is a electron withdrawing group. So that's why it gives the H plus ion. See the stability of this ion. If it is more stable, this phenol is more acidic. Now this is electron withdrawing group. It withdraws the electrons from which one? Benzene. Benzene, if it is group is withdrawing the electron, benzene withdraws the electron from oxygen. And so that's why on the oxygen electron density decreases, because the electron density on the oxygen is taken by which one? Benzene. So that's why electron density on the oxygen decreases. Electron density decreases means what? Charge is decreasing, negative charge is decreasing. So that's why charge decreases, stability increases. So it is a more stable. If it is more stable, acidic nature is more. So it is a more acidic. So from this we can write here, whenever electron withdrawing groups are present on benzene, whenever electron withdrawing groups present on benzene, it increases the acidic strength of phenol. Acidic strength of which one here? Phenol. This is the concept. Yes? Whenever electron donating groups are there and the acidity of the phenol decreases, whenever electron withdrawing groups are there and the acidity of the phenol increases. Clear? So this is one concept. Now, whenever donating groups are present at ortho position, meta position and para position, What about the acidic nature of the phenol? That we have to discuss now. Clear? So simply now this understand electron donating groups decreases the acidity and electron withdrawing group increases the acidity of the phenols. Now next concept is here. I will take some groups on the benzene ring and the positions I will change, and at ortho position, para position and meta position. So what about the acidic nature of those phenols? Yeah. And first one I will write here phenol. This is the phenol. So this question they have given in the answer test book. Phenol. Clear? And next one. Phenol means OH I will write in this way. So nitrophenol. Nitrophenol. Nitrophenol means first one I will write here orthonitrophenol. Clear? Next one is para-nitrophenol. This is meta-nitrophenol I will write meta-nitrophenol. And the third one is para-nitrophenol. And OH and here NO. So they will give the question like this, and they will ask write the acidic order of given phenols. Clear? Now you know that we have studied in the first year. NO2 group is a electron withdrawing group. Electron withdrawing group. So that's why just now only we have discussed electron withdrawing groups increases the acidity nature of phenol. Acidity increases. So compared to these three, and here electron withdrawing groups are present, but in the phenol there is no electron withdrawing group. So that's why phenol is the least acidic. Means you will get the compound here phenol is least acidic, because in the remaining cases electron withdrawing groups are there. Electron withdrawing groups increases the acidic nature of phenol. Clear? Now OH comes at last. Clear? Now among these three, which one has more acidic? You have to identify. Clear? So you know that it is electron withdrawing group. It will show the minus R effect, minus resonance effect also it will show. Clear? So you know it can also show the minus I effect. Resonance effect it will show, because whenever you write the resonance structure, on this carbon negative charge is there. This negative charge involved resonance with the NO2 group that we have already discussed in the alkyls and haloids. Clear? Once you see. So it is show the minus R effect and also minus I effect. And previous also I mentioned in the alkyls and haloids, resonance effect, hyperconjugation, and these effects will not operate from at the meta position. Only inductive effect operates at the meta position. Clear? And here, and resonance effect is operated at the ortho position and para position only, not at the meta position. Clear? So that's why NO2 group is present at meta position, so that's why it will show only minus I effect. But NO2 group is there and it will show the minus I effect and also minus R effect. You know, always remember some one exceptional case is there. Remaining all cases, resonance effect always dominates the inductive effect. Resonance effect always dominates the inductive effect. So that's why we need not to consider here inductive effect. But in this case we have to consider inductive effect. You know, minus R effect and minus I effect, both are electron withdrawing groups only, withdrawing effect only. So that's why two effects operates here. But here how many effects operates? Only one effect. And here also how many effects operating? Two effects. Due to two effects, minus I effect, withdrawing effect, acidic nature will be more. Yeah? So that's why compared to meta, ortho and para will have more acidic than the meta. So that's why next what you will get here? Meta-nitrophenol. OH and here NO. Because here acidity is increases due to the two effects here. But here acidity is increasing because of how many effects? One effect. That is. Now coming to these two, ortho effect and para effect. You know, resonance effect is the extent of resonance effect at ortho and para same. When it NO2 group is at ortho position, R in para position, the extent of resonance is same. But inductive effect is different. You know, first year you have studied, as the group means inductive effect, it depends upon the length. As the length increases, inductive effect decreases. So that's why, if you come to here compare these two, resonance effect both in cases same only. Now we have to compare the which effect? Minus I effect here. Minus I effect here. OH is NO2 is very close to NO2 is very close to OH, but here NO2 is very far away from the OH. So as the distance increases, minus I effect decreases. So here distance is less. So here minus I effect, withdrawing effect is more. So withdrawing effect is more means acidic nature will be high. So that's why which one should have the more acidic character? This one, and here we have to write, and here OH, NO2. And the next one you have to write here OH and NO2. But these are wrong. These are wrong. Why? Because means in orthonitrophenol, there is a chance of hydrogen bonding. NO2, O minus and double bond and plus. See, there is a chance of hydrogen bonding. Whenever there is a hydrogen bonding, you know, it is remove of H plus ion is difficult, because previously it is bonded with one hydrogen, means one bond. Now another bond is coming, so removal of H plus is difficult. Removal of H plus is difficult means it is a less acidic. So that's why, and first comes here paranitrophenol, and next it comes orthonitrophenol. This is the acidic. So why orthonitrophenol is less acidic means because of actually orthonitrophenol should more acidic than the paranitrophenol. But why it is less acidic means because of hydrogen bonding. Yeah? The same question it is there in your NCERT textbook. Index questions are there. In that one they have. Yeah? Now this is the acidic part. Next one, another question also they have given on the cresols. Yeah. So now I will write OH here. Cresol means we have already discussed in the common name. On the benzene ring CH3 and OH is there. This is cresol. This is orthocresol, and the next one is a OH, and here metacresol, and the last one is paracresol. This is CH. Okay, simple. Now you see, methyl groups are electron donating groups. Whenever electron donating groups are present on the benzene ring, the acidic nature of the phenols decreases. So compared to phenol, these three will have less acidic, because phenol doesn't have any electron donating groups, but here electron donating groups are there. Electron donating groups decreases the acidic nature, so that's why which one comes first here? Phenol comes first. This is the first. Now you have to compare here acidic nature of these three compounds. Clear? You know, whenever CH3 is there, in the first year we have already discussed, it involved in the hyperconjugation. It involved in the which one? Hyperconjugation. And also it is a electron donating group. It can also show the which effect? Let's say effect. But hyperconjugation is not operated at the meta position, so that's why here only let's say effect. And here there is a hyperconjugation and let's say effect. Both hyperconjugation and plus I effect, both are decreases the acidity of the phenol. Both are what it is, releasing groups only, releasing effect only. Yeah, so that's why. And acidity is decreases due to the two effects here, but here one effect. So that's why this is more acidic than these two. Clear? So that's why next one what it will come, and you will get the metaphenol. This is more acidic. Now compare to these two. Now it is more acidic because phenol acidity is decreasing due to the two effect, but here decreasing due to one effect. So it is more acidic. Yeah. Now here we compare hyperconjugation, plus I effect. Here phenol acidity decreases due to the two effects. But you know, hyperconjugation resonance when they are present at the ortho and para, they show the same extent. So you have to see the inductive effect. You know, as the length increases, inductive effect decreases. Here it will show the more inductive effect, more donating. So that's why less acidic. So that's why it is a more acidic. So that's why phenol, and here which one is there? CH3, and after them you have to write here phenol at 6. This is the acidic. Yeah, simple. And the last one is there, and in the same way, if OCH3 is there, you have to write it the same way. And you see now, I will just discuss. Suppose OH is there, and phenol, OCH3, and the next one is phenol, and the meta position OCH3 and phenol at OCH3 para position. Clear? Now you see, it will show the lone pair of electrons are there. It can involve in the resonance, so that's why it is giving electrons to benzene plus R effect. Oxygen is there, electron withdrawing group, so that's why minus R. And carbon and oxygen, which one is more electronic? Oxygen, so it takes the electron from the benzene ring, so it is a minus I effect. And here, there is only minus I effect, there is no plus R effect. And here, plus R effect and minus I effect. But I already mentioned, always resonance effect, it dominates the inductive effect. So that's why we have to just consider OCH3 is there, and at oxygen para position we have to consider only the resonance effect. Because resonance dominates inductive. So if you compare here acidic strength, see now, minus I is there, plus R is there. Which one dominates here? Plus R. So that's why it is a plus R means electron donating. Electron donating decreases the acidic strength. Here also plus R because it dominates the minus I. Plus R means it gives the electrons to benzene ring. So that's why it is electron donating group. It decreases the acidic strength. But here which effect? It is not plus R. It is which one? Minus I. Minus I means what it is? If withdrawing group is present on the benzene ring, more acidic. So you will get the first one here. OH and OCH3 is more acidic. Next one. Here plus R. Here also plus R. Plus R means what it is? Electron donating. Electron donating groups are there. Acidity decreases. So here there is no plus R group. Next it will come phenol. This is phenol. Clear? Next one. You have to compare the ortho and para. Ortho and para, R effects are same. You have to compare now which effect? Minus I effect. If you compare the minus I effect, minus I effect is very high at ortho position. Clear? So that's why minus I means what it is? Electron withdrawing. Electron withdrawing is more when it is very close to the OH ortho position. So you will get it is more acidic OH, and here OCH3, and finally you will get the compound which is here phenol and OCH. These are the acidic strength of which one here? Alcohols and phenols. Next concept is esterification. Okay? So what is esterification? And whenever alcohols or phenols reacted with the carboxylic acids, alcohols or phenols reacted with the carboxylic acids and produce in the presence of acidic medium like concentrate H2SO4, and gives ester plus water, and that reaction will be called as a esterification. Yeah? And first of all, alcohol. Alcohol means what it is? ROH plus acid. Acid means what is the general formula? RCOOH. RCOOH in presence of acidic medium. And you can take the concentrate H2SO4. Yeah? RH plus what we can take here? Concentrate H2SO4. This is the acidic medium. Yeah? Then you will get the compound is water molecule will be removed. And here H and here OH will be removed. This is. Yeah? Then what happened you see? And to the RCO and OR will be added. So what you will get here? I will write here this is R dash for the just identification. So what I will write here? R and here C double bond O, and there will be a OR plus what it is here? H2. And and this reaction we will consider it as a esterification. The formation of esters from the alcohols and carboxylic acids is called as esterification. In the same way, phenols also will react in the same way. Yeah? If you take here phenol, alcohol in simple example I will take CH3 and suppose C2H5OH plus acid means I will take here acetic acid CH3CO and here OH. So and same in the presence of H plus ion, then what happened? H from the alcohol, OH from the OH from the acid. Yeah? Then what the compound you will get? You will get the CH3 and C double bond O, and you will get the O C2H5. What is the name of this compound? This is what it is, ester. It is ester. It is ethyl ester. It is a which one? Ethyl ester. Plus what you will get here? Water plus H2. Yeah? In the same way, phenol also. If you take here phenol and here OH plus acid and CH3 C double bond O and OH and remove the H from the phenol and OH from the acid. This is important, I will discuss. And you will get the compound is and CH3 and C double bond O, and you will get the O and phenyl. And what we can call here phenyl acetate. Phenyl acetate. This is the which medium we have to maintain here? We have to maintain here acidic medium. Yeah, and this reaction we will call as a esterification. But very important here, always remove the hydrogen from the alcohol and OH from the acid. Clear? And why means, and that will be discussed in the carboxylic acid. And stuff is there, aldehyde, ketones, and carboxylic acid. There I will discuss. Clear? But remember, concept is always remove the H from the alcohol and OH from the acid. Don't do in the reverse. OH from the acid and H from the OH from the alcohol and OH from the acid. Don't do that one. Yeah? So this is what we will call esterification. And the next one is there here, acetylation. Acetylation of alcohols. Acetylation of which one here? Alcohols. Yeah? Alcohols and phenols. Alcohol and phenols. Yeah? So acetylation means what we have to do. Same. Take the alcohol here. Take the alcohol and consider here acetyl chloride or acetic anhydride. Whatever it may be. Both are used for the acetylation only. What is here? You can take the acetyl chloride or simply acyl chloride or COCl. Yeah? But you have to use here in catalyst is pyridine. Pyridine you have to use. Here what you have to use here? H plus acid. But here what you have to use? Pyridine. Then what happens you see? And remove the H and Cl here. HCl will be removed. Then what you will get? I will put R gas. This is R gas and CO and OR. Clear? Plus what you will get here? HCl. Because in this reaction acid is generated. To normalize the acid, we will use the pyridine. So now what it is you see? Instead of the H is substituted by the RCO group. This is alcohol. ROH is an alcohol. H is substituted by which one? Acyl group. So that's why we will call this is a acetylation reaction. Here also what is the compound you will get? Ester only. This is also ester. But it is H is replaced by the acyl group, so that's why we will call as a acylation. In the same way, you can take any example here. I will write here first of all CH3 and you know C double bond O and Cl, and here I will take C2H5OH. Then we have to maintain which one? Pyridine. Why we will use pyridine? To neutralize the acid in the reaction. Then what happens you see? HCl will be removed, and then what the compound you will get? C2H5O and C double bond O CH3 acetyl group. That's what we call as a acylation. Clear? So that's why you are getting here ester. Clear? And in the same way, phenol you take the phenol and here OH and plus take the acetylation, do the acetylation here, CH3 COC here, and H and Cl will be removed here, HCl. Then what the compound you will get, you see, you will get the compound is O and CO CH3. Instead of H is what is there? Acyl group, so that's why it is a acylation of alcohols and phenols. So this is the reaction of the esterification of the phenol and alcohols, and here also acetylation of alcohols and phenols. Next one, in the NCERT textbook they have given acetylation of salicylic acid. Acetylation of salicylic acid. You know what is the salicylic acid formula? On the means benzene ring there is a COOH and OH group. This will be called as a salicylic acid. This is salicylic acid. Yeah. Now you have to do the acylation. I already mentioned for the acylation you can use the acetyl chloride or acidic anhydride. Acetyl chloride I have already explained here by taking the acetyl chloride, and we can take the acidic anhydride also for the acylation. So if I take the acidic anhydride CH3 COO and COCH3, it is acidic anhydride. Clear? In the presence of H plus. Okay, then what will happen here? Acetylation takes place. Acetylation means which group should be added? COCH3 group. So here what happened? H this is a group will be removed, and here CH3 COOH acid will be removed. CH3 COOH. This acetyl group CH3 CO group will be added here. So attached. Then what we will get here? COOH and here OCOCH3. This is the compound OCOCH3, and this compound we will consider as aspirin. Yeah, it is a one drug. It is a one drug which is used for reducing the means for fever and also to relieve from the body pains. And this is the acetylation of which one here? Salicylic acid. And sometimes they may ask how the aspirin is prepared. And take the salicylic acid and do the acetylation by using acetyl chloride or acetic anhydride in the presence of H plus, and you will get the compound is, the compound will be called as a aspirin. So here CH3COOH acid and aspirin. So what is the name of this compound? Acetyl salicylic acid. You can write here acetyl salicylic acid. Salicylic acid. And this can also be called as a aspirin. So this is one of the drug, and this is the acetylation of salicylic